Today's lesson is on the roles of variables in Scratch. Variable roles are the reason why we are using a variable. Variables are used to remember data so that we can use that data at a later point. But why would we want to remember data for a later point? Well, there are lots of reasons for that. What are variable roles? Variable roles are the reason that we use a variable, and certain ones keep coming up repeatedly over and over and over again. 8 of these roles include 90% of the ones that you folks in your first year of programming are going to be using. Those 8 roles include a fixed, stepper, accumulator, bestsofar, most recent, walker, aggregator, as well as a one-way flag. A fixed variable is assigned once and then stays the same throughout the program. Accumulator is a running total. A stepper is a predetermined sequence of values. Let's say we're counting 1, 3, 5, 7, 9. A bestsofar is like a record holder, such as a high score or low score. Most recent is assigned unpredictably. An aggregator is a running list, okay, kind of where you keep adding things onto the list or collecting things. A walker represents the elements of an iterator. Again, an iterator is something that repeats itself, for example, in a loop. And a one-way flag is one that stays the same and it doesn't get reset until after it's finished whatever iteration it's at. Variable roles say why we're using the variable. The roles are not syntax. Examples of syntax indicate whether the variable is used in a conditional. Conditional would be like in an if-else block or in an expression or in an assignment block, like we're storing, setting a value equal to something. So we're setting a variable x, let's say, equal to 5. Why do we want to use a fixed variable? Well, a fixed variable helps us to create one place, a single place where we can tweak or set a number that's used throughout the program. So it makes it nice and easy to go ahead and set it in that particular spot. It also makes the code easier to read. Why is it that number, why are we subtracting by that number, that same value all the time? Why are we multiplying by that number 3.14 over and over and over again? Let's say pi is our constant, 3.14. It also makes it easy to add features, so the user decides on the constant. So let's say, for example, initially I write the program and pi is my variable, is my fixed variable. Well, pi initially I set to 3.14. Later on I decide, okay, I think I want to add some more digits. If I set it as a fixed variable, later on I just go ahead and then I set pi equal to 3.14159. So it's nice and easy to go ahead and change it. I change it in one spot, and the change carries through throughout the entire program. In a fixed variable, at the head of the program, okay, we'll go ahead and assign it. Here it says set move increment to 5. Right? So move increment is initially set to 5. We always assign it at the beginning of a program or the beginning of a code block, and it's used, but it's never assigned again. So essentially the value that we set it to is always going to stay the same. Now the convention is that it's all caps. So anytime you see something that's all caps, such right here, move increment, you're going to go ahead and know, because it's all caps, that it's going to be a fixed. Most recent is used to retrieve or calculate information once, okay, but we can use it multiple times, many times over and over and over again, and it could change. We can also use it if we need to remember where we are. For example, if we wanted to remember which level we are in a game, let's say, in case we need to remember what the user inputted, let's say, for their first name until we need it later on. Could also be used to embed an explanation in the program. We can also use it sometimes to help us debug or fix problems in our programs. It's when we're assigning a variable as the most recent, the variable name appears on the left of the assignment, and then in a bunch of different ways, a variety of syntax. Syntax is basically just the way that the code actually looks. So an example here of most recent is we're setting the direction. Initially, we're setting the direction to 1. Later on, we're using that direction. We're going to multiply it by the move increment, and we're going to do something based on that. And then later, if it's touching the wall, direction gets set to -1. If the direction is less than 239, is set to 1. So in this case, most recent is unpredictable. Sometimes it's 1, sometimes it's -1. That's why it's most recent, because we're only storing what it was most recently. We're not going to remember what it was each step of the way. An accumulator is used to keep a running total or a cumulative value. We could be adding, we could be multiplying a number. Very often we'll initially assign an initial value before the loop. Let's say, for example, an accumulator is keeping track of a score in a game. Initially, the initial value would be set to 0, and then if we collect points, then we would go ahead and continue adding or subtracting points, maybe if for some reason you lose points. So we assign the value to using the statement change accumulator by inside a loop, and then we use the result after the loop. So an example here is we're setting our accumulator to 0, and then later when we click on the sprite, we change the accumulator by the mouse. All right, an accumulator is our variable. It's going to keep track of, in this case, we're going to keep adding or subtracting the correct value that we're adding to the accumulator. Again, one example could be if you're trying to keep track of a score inside a game. And scores could go up, they could go down depending on what the game is. An aggregator is used in case we need to collect items and we need to remember them all separately. Now, my oldest son is real big into Minecraft, right? And in Minecraft, you collect all sorts of stuff, pigs, food, all sorts of stuff. So the game like Minecraft, wherever that location is where you're storing all of your stuff that you collect is an example of an aggregator. Pokemon Go would be also using an aggregator as well. My son is also big into Pokemon Go. So when you collect all the Pokemons, they get stored in a certain place. That list of things that where they're stored is called an aggregator. Typically, we'll initialize it to an empty collection. So before you start Pokemon Go, you have nothing, or before you start Minecraft, you start nothing. And then you keep appending or adding on to that aggregate as you play the game or as the loop continues. And that aggregate gets used during or after the loop. So you can go ahead and look through all of the things that you have later on while you're playing with, let's say, the game. In terms of Scratch, okay, when the flag is clipped, then we're deleting all of the aggregators. So basically this line right here just clears the aggregator, so there's nothing there. And then when we click on the sprite, we're adding that exposition to the list. So the first time they added the exposition, which is -107. Next, they clicked on the same exposition, but stored at -107. Next, they stored 14. Next, it stores 14. And next, they stored -147.95. In this case, our variable is storing numbers. But again, you could have an aggregator not store numbers. It could store things like whatever you're collecting in a game, such as Minecraft or Pokemon Go. A stepper is used in case we need to go ahead and iterate or repeat a loop a specific number of times. We might also note that, let's say we want to keep track of which iteration is being executed. Is it the 5th? Is it the 7th? Is it 9th? Steppers are always used for integers. Okay, we could use it, let's say, also if we wanted to calculate a factorial. Factorial would, if I wanted to multiply 5 times 4 times 3 times 2 times 1, that's what a factorial is. So the common pattern looks like this. When we click on a sprite, we set the stepper to 1. Later, we go ahead and repeat this code. This code is blocked out here. We don't really need to know what's going on. And later, we change the stepper by 1, and then it repeats itself. So initially, the stepper is 1. We add 1 to it, so it becomes 2. Then it repeats again. Okay, it becomes 3. Repeats again, becomes 4. Repeats again, it becomes 5. A walker is used in case we need to remember which items we're looking at in your collection. So if we've got our aggregator, okay, let's say our aggregator is scrolling through and looking, or our aggregator is all of the Pokemons that we've collected in Pokemon Go. Stepper would be, first I'm going to look at item number 1. Okay, we're going to repeat the length of my list of aggregates. So if I've got 10 objects, I'm going to keep going until I reach the last one, which would be number 10. The walker is actually the first object. So let's say the first object, if the first one that I picked is Pikachu, okay, then the walker is set to be Pikachu, okay. Then we go ahead and look at the second item, okay. Well, then we change the stepper by 1. So now our stepper is 2, okay, and we're going to go ahead and say Pikachu, because Pikachu was our first one, and now we go back and we repeat, okay. We still haven't reached the end of our list, so then now our walker is no longer going to store Pikachu. Now we're going to set the walker to be Charizard, because maybe that's our second Pokemon. And then we change stepper by 1, number 3, and then we say walker. We say what the walker is, we say Charizard, and then we go back to the same repeat statement, and then go ahead and announce what the next Pokemon was that we collected. Scratch requires that we index a stepper, okay. Python and Java are a little bit easier than that. Okay, here's an example in Python's code, or Java. For fruit in the fridge, we're going to do something with our fruit. We'll notice in this case, this code doesn't actually refer to any number. In Scratch or some other languages like C++, we always have to have a number. So stepper has to start at a number 1, okay, and then it can go ahead and keep going until we reach the end of the list. Why would we want to use a bestsofar variable? We could use a bestsofar if we wanted to remember a record holder. For example, a high score, or maybe it's a low score. If your goal is, if it's a race car game, you want to pick the winner based on the fastest time, that would be a low score in terms of time, across many, many opportunities. So this, again, is going to be over the dozens or hundreds of times that we play this game. Typically, we'll first initialize it to the worst possible value before the loop. Okay, so if it's a game where we're trying to score lots of points, the worst possible value maybe would be a -1. Okay, and then whoever plays the game first time is always going to get better than -1. So you go ahead and then reset it to that value. During the iteration, again, you compare it back to that bestsofar, and then maybe assign a new record. Right, and then once it's done, once you're done with the loop, then the bestsofar is used as a true record from all of those iterations. One of the things I like to play with my kids, sometimes I'll play those dance games on the Wii, or maybe one of the singing games on the Wii against my kids. So we'll go ahead and compete to see who can get the best score on a particular song. So far, I'm usually the one getting the high scores for most of them. That was my daughter, by the way, who somehow thinks that she's beating me on some of the singing and dancing game. That was my daughter, Sandra. Hi, Sandra. When we're setting a bestsofar, we always, first we initialize the value. So here we're setting our record to -250. If you remember, the screen on the Scratch, the x-coordinate, starts at -249 and goes up to +249. So we're setting a value that's less than -249. That way we always end up setting the record first time through. Now we're going through the entire aggregator here. If our walker is greater than the record, which it will be because it has to be greater than -249, then what we're going to do is we're going to set the new record. So let's say the next location they click on is -240. So then our record is -240. Then we go ahead and repeat, go through the entire loop. And then when the loop is done, okay, after checking and setting all those records, when the loop is done, then we go ahead and report it. Once the loop is done, we go ahead and say what the record is once we're done. A one-way flag is the last type of variable role, and a one-way flag is typically used in case I need to remember whether or not some opportunity is done, whether or not something has completed. One example of a one-way flag could be in a video game. Let's say you've got 3 lives. At the end of the 3rd life, your flag is set to 0, and then all of a sudden, no matter where you are in the game, basically you lose the game. Okay, so your flag is initialized to say the opportunity that hasn't been met. The game is not over yet. Okay, later, each time through the game, as we play, we check to make sure that the game, we still can play. We haven't had a life set to 0. Then we raise the flag once we've lost all of our lives in the game. We raise the flag, and then the flag doesn't get cleared after the loop. We check it, okay, and then again, if if the flag has been risen, if the flag was raised, okay, or if our lives went down to 0, then we're done. The game will go ahead and end. And typically we start out first, we initialize to clear the flag. So here's our example here. We're setting our flag to false. Here our flag is set to true false. Okay, so is it the end of the game? The flag is set to false. And no, it's not at the end of the game. As we're playing, okay, as we're going and playing with the game, we still keep doing whatever we need to do. If for whatever reason the game is over, X position is greater than 50, we set the flag to true. Okay, so here we're checking and raising the flag, and then later on we're broadcasting it, so we're announcing it. So basically the flag is being announced, the game is over. Here's an example of another one-way flag. In this case, we're using a procedure instead of a broadcast. So the same pattern is evident. We always initialize to clear the flag. So here we're setting our flag to false, meaning at this point our game has not ended yet. Later on, as we're playing our game, okay, we're on a regular basis, we're checking to see whether or not we need to set the flag. So if our walker is set to whatever that is greater than 50, then we set our flag to true. So then we check it, we raise the flag when it's appropriate. So then let's say if that now the goal is once the flag is raised, then the game is over, everything's ended. Then if the flag is set equal to true, okay, then we go ahead and announce it, we go ahead and report it.